Can somebody tell me what did we see in our last class? Machine cycle is very important. We'll solve some problems, okay, this week. So tomorrow we'll solve some problems based on machine cycles. Let's continue some facts about the hardware components of 8086 microprocessor. Okay. Hope you remember yesterday in my class I have told you that address data bus is multiplexed. Right? When the address data bus is multiplexed, so when you use those address data bus as a separate address bus and separate data bus, you need to demultiplex. Yes or no? You have to separate it out. Okay. So how to do that? There is a separate hardware available to do that. Right? Okay. Multiplexed address data bus has to be working as an address bus whenever it generates an address. Okay. It has to work as a data bus whenever microprocessor wants to exchange data between memory and the microprocessor. So one device, two roles. Right. So how to do that? How does microprocessor converts address data bus to address bus, and it converts address data bus to data bus? What is that? I already told you about that. So this slide explains you the same thing. Okay, we are going to use something called as a latch. What is latch? Octal latch. Can you tell me what is latch? Have you seen a latch? What is latch? Latch means what? You have used SR latch, whatever input, okay, will appear at the output. You have D latch. Have you seen D latch, which is making use of D flip flop? What it does? Tell me. Whenever the clock goes active, okay, whatever input will be appeared at the output. And see this. This is called octal latch. Listen carefully. This is called as octal latch. Why it is called octal latch? Because there are 8 inputs. This one latch has got 8 inputs. The integrated circuit name, the IC has been given name. Entire octal latch has been fabricated as an integrated circuit. That it's somewhat like you have AND gate, NOT gate. All the gates have been given a number. Yes or no? Right? Like 7400, 7403, and so on. Like that, this latch is given a symbol of 74LS273. Okay, so 74LS273 is a latch. Okay, so what happens? How does it work? See here, there is a pin B. It has got a G pin. Okay, and also it has got another enable pin called as output enable pin. So what happens? Whenever you give 0 to this pin, output enable, that means this particular pin will get activated, and you give high to this, whatever input you give here will appear at the output. This is what the latch is. When this is 1 and nothing will happen, that means output will not be enabled at all. Right? Okay. Now, when this is 0, listen carefully, and this is 0, what happened? Tell me. Whatever input you give, will it appear in the output? No, because you are giving this G input as a 0. Right? So this is used to separate your address data bus, separate address data bus as an address bus. So what you do, whenever microprocessor generates an address, okay, why microprocessor generates an address? It doesn't have any work, right? Why microprocessor has to generate an address? Tell me now, you tell me. Microprocessor generating the address means it is going to fetch the data from the memory. I've understood this. That means when the microprocessor generates an address, it has to go in address line only, right? It doesn't go in data lines. So that means your multiplexed address data lines has to be used as an address line now. I understood this. Now what happens? There is another pin called as ALE. I told you about this in my last class. Address latch enable. And this address latch enable goes automatically high when microprocessor generates an address. Remember this. So if you connect your multiplex address data line to this, okay, your multiplexed address data lines to this, and your ALE goes high, okay, and this is 0. What happens? Only when ALE goes high, whatever is there in this address data bus, address data line will appear here. That means whatever you get here is going to be your address line. So this is going now separating. This is separated now. This is separated as only address line. So address bus is a separate address bus is connected to this side. But this side you will have both address data bus, multiplexed address data bus. So have you understood now? So ALE is connected, address latch enable is connected to this. Right? So when ALE goes low, this side is your address bus. Right? This side is your address bus. This side is your only address bus. Okay, address lines. This side is both address and data lines. Now you see here, whenever your ALE goes high, whatever is there in this, it will appear here. When ALE doesn't go high, ALE is not high, you see here, whatever is there this side will not appear here. Why? Because it is not an address. I have understood this. This is the way you can demultiplex your address data bus into separate data bus and the separate address bus. Understood this? Okay. This is the hardware concepts of 8086 microprocessor. And you can also see that remaining address lines. Okay. So remaining address lines also multiplexed with other status signal. We will see that whenever we come across with that. Right now it is not required. See this, how you are going to, this is very important. This is very important. How you are going to separate your address data bus to a separate address bus, separate bus I enable, separate data bus. See, in this picture you are going to separate only address bus. Right, see here, this is your microprocessor side, this is your microprocessor side, okay. So now you see here, see you have LS373, 273 is all going to be same thing, okay, don't worry about it. And you know, in microprocessor side, your address data bus is actually multiplexed. You know, see here, it's written 80 to 87. So why I'm actually separating it to a bunch of 88 bits? Tell me. Because my devices can take only 8 inputs. I may be having 16 data lines, right? So as to demultiplex 16 data lines, I require 2 octal. These are all octals. That means it has got only 8 inputs. That's why I'm separating it into 8 lines here, right? But actually, your microprocessor will have 16 address data lines, multiplexed address data lines, right? Which works as both address and data. and remaining address lines, that is your A16, A17, that is also multiplexed with some other status signal. Now we have to demultiplex. How to do that? See, this is your microprocessor part. Okay, you have this AD0 to AD7 multiplexed address data bus, address data lines, I'll call it data lines. All lines together, it constitutes a bus. Okay, now see, it has got address data lines AD0 to AD7, AD8 to AD15, and also you have this remaining address lines also multiplexed with this. Now you have to separate it. Bus high enable also multiplexed with S7. Now you have to separate it. Okay, so you know that whenever address latch enable goes high, address latch enable is a signal, I already told you, I'm repeating it every time. Okay, whenever address latch enable goes high, then the AD0 to AD16 and also A16 to A19 should act as only address lines, nothing else. For that, these are used. These latches are used. See, you are going to connect your AD0 to AD7 to this. See here, AD0 to AD7 to this one of the latch, and another AD8 to AD18, AD8 to AD15 to this latch, because the total lines which are multiplexed are 16, but this can take only 8 inputs. That's why we are using 2, right? And see here, this is the ALE. Now this ALE is connected to this G. Can you see here? It's connected to this G. So these two LS373s will separate this AD0 to AD15 to A0 to A7 and A8 to A15. Right? Understood this. Now, what about remaining address lines? Because microprocessor has got address lines from A0 to A20, right? A20. You have separated A0 to A15 here. What about A16, A17, A18 and A19? That is also already multiplexed with this, right? So there also you connect ALE, okay, and connect your address lines here, and it is separated as A16 to A19, and this is also demultiplexed, and you get bus enable separate. This is called as a sort of demultiplexing. So this generates the address lines. This circuit is actually required. This is connected external to the microprocessor. This is external to microprocessor. Okay, this is not there inside microprocessor. This is a microprocessor 8086. These ICs are connected, and what you get this side is address bus. So this is the address bus. This is not data bus. This is only address bus. So multiplexed address data bus is now become only address bus. Understood this? Okay. So this is a completely hardware circuit. I already told you about write signal and the read signal. Write signal, read signal. I already told you what's the purpose of write signal. Microprocessor will generate a low in the write signal, that means whenever it wants to write a data to either to memory or IO bar, depending on the whatever bit you have in the memory by. Here also you need one multiplex. Right, you need a circuit. Right, see, you have this one and this one, and your read signal has to generate memory read, that is a memory read signal. There it has to generate memory write signal, it has to generate IO read signal, and it has to generate IO write signal. The 4 signal has to be generated from these 3 pins. Right? So how do you, can you just deduce a circuit for that? I'm just giving you a small homework on this, which you can do it by just taking a knowledge of your digital design. Right? See, you have memory bar, memory IO bar, one variable, read bar, right? Then you have write bar. These are the inputs, okay? These are the inputs, right? Now, you have to make 4 outputs out of this, right? How to do that? It's very simple. I'm just doing it for you. See here, memory IO bar, read bar, and write bar. See here. So I will write memory read. This is very easy. Just concentrate here. If you want to learn, memory write, IO read, IO write. Okay, IO write. I have this. Okay, so I have these three pins in a microprocessor, but I have to generate 4 signals out of this because my memory write, memory read, IO write, IO read signals are separate 4 signals. Okay, now see here. Suppose for this pin, if you give one, that means whether it is a memory read, memory write, IO write, okay, it is actually doing only something with the memory, right? So whenever I put 1 here, that means this will be activated. That means whatever data transfer, whether it is read or write, it will be with respect to memory only. Suppose if I give 0 here, that means whatever read and write you do, it will be with respect to IO. Okay. Now suppose if I give 0 here, right, and if I give 1 here, can you tell me which one of the output goes to 1? It is memory right. It's memory write, right? See, memory read. Is it memory write? See, this will be activated. This is active low signal, right? When you give 0 here, this will be activated, right? So that means when you give 1 here, 0 here, and 1 here, right? Can you tell me what is the combination you are going to get? Where you get 1? You should get 1 here. All these should go to 0. All this should go to 0. Now, tell me now. Whenever this is 1, this is 1 and this is 0, can you tell me what will go 1? What should go 1? This should go 1. All should go to the 0. Now, when this is 0, this is 0, this is 1, can you tell me which one should go high? IO read should go high. Now, see, when this is 0, this is 1, this is 0, can you tell me what should go high? All this should go low, this should go high. Now, these are the signals available from microprocessor, and you have to generate this. Right? Can you tell me how do you generate these signals? You need a decoder. Why you want to go such a complicated one? Can you just write a simple combination circuit for this? Decoder is also a combination only, right? Right. So you get an expression for memory read in terms of these inputs. You get an expression for memory write in terms of these inputs. You get an expression for IO read in terms of these inputs. You get an expression for IO write in terms of these inputs. Form a circuit, that's all. Form a simple circuit. So from these 3 signals, you'll get the 4 signals. That's also part of the hardware of microprocessor. I'm just explaining you once again because you already know it, so I don't want to. This is what I have told you, right? You have to generate these 4 signals, okay, using the circuit. This is what you can just generate. Simple circuit, right? So is it not going to generate the respective signal? Right? When this is 0, this is 0, this is generate 0, right? IO operation. This is 0, this is 0, it will generate. Simple gate, it can give you that circuit. See, this also. So how do you get this? Just from this, whatever I have explained to you here, just get an expression for this in terms of these 3, that's all. Right? Okay. Data enable. What is data enable? Hope you remember I told you during my last class. What is data enable? Exactly. See, we have seen how to separate your address bus. And address bus is unidirectional. Latch will work there, right? But this one is bidirectional. Data bus is bidirectional. We need something else. Have you understood this? Okay. You cannot use 74LS 373 or 273 for that. But you have to use something else. Okay. So data enable is something whenever it goes low. Okay. That means your data bus can be enabled. Address data bus can be enabled as only data bus. You're going to separate it into the data bus. Okay. There we use a device called as buffer. So have you heard about buffer? Buffer. This is called a tri-state buffer. Tri-state buffer it works like a latch. It's like a bidirectional latch, right? It's something like it has got a feedback connection of 2 flip-flops. What it does is it will allow input from one side to other side and also from other side to input side, right? That's what's called as buffer. Buffer is a digital device, okay, which will allow the input to go from A to B, okay, and from B to A. Understood this? Okay. So whenever you enable this particular pin, okay, by giving 0 here, this is not called as buffer. Okay. For address, we have used latch because only one directional data is enough for that. But for data, you need 2 directional because data can either go from microprocessor to the memory or IO, or data can go from memory or IO to the microprocessor. So there is a bidirectional data transfer between microprocessor and the other devices, memory devices or IO devices. That's why whenever you separate address data bus as a data bus, whatever you use in between should be a bidirectional, should not be unidirectional. That's why we use the buffers here, buffers. Okay, so this is what buffer. Buffer, for time being, you just remember it as it's like a latch. Okay, but it can just transfer from both directions. Okay, it can A can transmit to B or B can transmit to A. This is what the buffer is, right? And you see that the exact picture of this is this one. See here how it is actually this is nothing but one latch and this is another latch. It's connected in the reverse opposite way, right? This is a buffer. This is a buffer. Whenever you enable this chip, okay, depending on the direction you give, okay, either data can go from A to B, okay, or data can go from B to A. For example, if you give 0 to this is enable pin. This is E bar. When it is E bar, it means that whenever you give 0 to that, this will be enabled. Otherwise, this will not work. And direction 0, A can connect it to B. Data goes from A to B. Whenever you give 1 here, data goes from B to A. So accordingly, you can program this simple configuration of this. Okay. Now, how do we use this in separating the data bus? Right. Okay. So now, see here. This side assume that you have address data bus, address data lines. Right. This side you have address data lines. Okay. So whenever your data enable goes low, I told you, right? That means microprocessor is actually using address data bus as a data bus. That means it is actually supposed to exchange data, right? So address data bus, multiplex address data bus should be used as a data bus, right? So connect your data enable to this buffer. This side is your pure data bus, right? Okay, and according to the data transfer or data receive, there is a pin called data transmit data receive. Data transmit data receive is a pin in 8086 microprocessor. Whenever you have one in this pin, that means it transmits the data. Microprocessor transmits data from microprocessor to IO or memory. Whenever this particular pin is showing 0, means it receives the data. Microprocessor is ready to receive the data from either memory or IO, right? So now depending on that, these functions. So whenever microprocessor wants to exchange data, right, its address data bus, multiplex address data bus, that means it is now data bus, right? So during that time your data enable goes low. Data enable goes low means this chip will be activated. When this is activated, same time whenever microprocessor wants to transmit data, this will become 1, right? So whatever data available in address data bus will be available to this data bus. Have understood this? Now whenever microprocessor wants to receive a data, same time it will make data enable goes low, but this it will make it as 0, right? So that time what happens? The data will go from the data bus to the multiplexed address data bus connected to the microprocessor. Microprocessor receives the data to the other side. Understood this? So this hardware is used to separate the address data bus to the data bus. Earlier we have seen we have used latch to separate your address data bus to address bus. We have used buffer to separate your address data bus to data bus. So you are actually demultiplexed your multiplexed address data bus to address bus and the data bus. So which is the control signal to separate these two? One is ALE and data enable. In data enable, once again you have receive and data because it's bidirectional, right? In address we didn't have any data receive transmit. Why? Because address is unidirectional, one direction. It just goes out, that's all. It doesn't come inside. Understood? This is the extra hardware which is made external to the 8086 microprocessor. Whatever we are discussing is not the hardware part, okay? I have already explained to you about this. See here. Once again, why 2 here? Because it's once again octal. Because you have AD0 to AD16, right? AD0 to AD16. So AD0 to AD16, this is microprocessor side. Okay, it makes use of data enable and data transmit read. And this side you have only data bus. This is only data bus. And this is bidirectional. Just have a look into this. This is bidirectional. And what is this? This is your buffer. This is your buffer. So hence you use latch and buffer to separate your address bus and the data bus, because your address data bus is multiplexed when it comes to the microprocessor side. Okay. So now you understood. Whenever microprocessor generates an address, okay, moment you just start executing your instructions in microprocessor, first thing what microprocessor does is generates an address. It generates an address, put it in the address data bus of its own address data bus here, right? So it is an address, and same time it will generate an ALE signal, right? It won't make your data enable low at that time. It will make ALE high at that time, right? So what happens is ALE goes high through latch. The whatever data available in address data bus will be going to the address bus now. Now immediately once the address goes to address bus, immediately ALE goes low. because it doesn't require, right? Then after that, when the microprocessor wants to read or write the data, data enable goes slow. Data enable goes slow. Depending on data transmit and read, it will either read or write the data. I've understood this. Okay, that is what we're going to see. It is a timing diagram. Timing diagram is very interesting. We will just learn about it. Okay, hope you understood. This is to separate the data. I already told you about all these signals. Okay, all the signals I have told you. The same thing. Same thing. Can you tell me what is this? Can you tell me why I have made this minimax to be connected to 5 volts? It is working in the minimum mode, right? So hope you remember the difference which I have told you during my last class. What is the difference? Minimax mode. In maximum mode, a microprocessor can be associated with the coprocessors. Right? When the microprocessor is working alone, alone, right? Then it is minimum. Okay?